All right, so this next packet is on Chapter 5, Polynomials and Factoring. So pretty much everything we're going to be seeing in this packet is a refresher, and also we'll be taking it a little bit further with an extension of what you saw in Algebra 1. So we'll be looking at polynomials, we'll be looking at factoring, we'll be looking at exponents, all different things today and in this packet. So if you open up to the first page, we are going to first be working on section 5.1, which is integer exponents and scientific notation. So just a refresher here, we have an expression 4 to the third power. And 4 to the third power is the same thing as 4 times 4 times 4. 4 is considered the base number, and that little 3 that's above it is called the exponent. The exponent tells you how many times the base number is going to be multiplied by itself. So to get this solution, you would just either by hand expand it to be 4 times 4 times 4, and in your calculator hit enter, or your calculator also has the ability to just put the exponent in by using the little caret button, which is above the division symbol. You would just hit 4, and then that caret button, 3 equals, and it would simplify it for you. So an exponent is used to represent repeated multiplication. The expression above reads 4 to the third power. Like I said, the base is 4, the exponent is 3, and you would use this as the caret button I'm talking about. Exponents can be positive or negative, and exponents can also be fractions. So, rules of exponents. This chart here is going to be an example of all of these rules with variables and also with real numbers as examples. So, in the Algebra 1 textbook, in the Algebra 1 curriculum, you guys went through all of these different rules. So, you saw multiplying exponents, power to power exponents, dividing exponents, zero and negative exponents. But you probably forget a lot of this, and some of you might like this section, and some of you might be like haunted by previous lessons from previous years, and you're like, oh no, not this again. Unfortunately, this stuff can't be done in the calculator. I know a lot of the problems in the last section, like with the matrices and stuff, could be completed with the graphing calculator. These, you actually will have to know how to use these rules and memorize these rules. So the first thing for the table here, these table entries are going to all be examples with variables, and then these entries are all going to be examples, thank you, with real numbers. So the first one is the product rule. The product rule for exponents means if you have a number with a base a and it has an exponent of anything, I'm just going to say a to the b power. If I'm multiplying this exponent, or this number, by something with the same exact base, but it has the same or a different exponent, what you can do to simplify this is take that same base number and add the exponents together, and it still will be the same number. A to the b power times a to the c power is the same thing as a to the b plus c power. For example, if we do something like 2 to the third power times 2 to the fifth power, I could put this in my calculator separately, and I could do 2 to the third, hit enter, 2 to the fifth, hit enter, and then multiply the two numbers together. Or you could simplify this because they have the same exact base, the base being a 2, you could simplify this to be 2 to the power of the sum of the bases, which is just 2 to the 8th power. So what's strange about exponent rules is that when you have the same base and you're multiplying them, you take the exponents and you add them. So you have to like memorize that if it's multiplying, you add. So it's almost like the opposite situation. A product to a power rule is a little bit different in that this means that there's a product number, like any number a times b, and it's being raised to a different number like c as the exponent. This is a product because a and b are being multiplied, and product means multiply. To a power, c is the power, also known as the exponent. Anytime you have something being multiplied raised to the power, you can take this power and you can distribute it to both numbers inside the parentheses. This is the same thing as a to the c power times b to the c power. For example, if we have something like 2 times 3 in parentheses being raised to the second power, let's say. This product to power rule says you can take this little exponent of a 2 here and distribute it to both bases 2 and base 3. If I was to simplify this, you will get the same exact answer. On the left-hand side, 2 times 3 is 6. 6 to the second power is 6 times 6, which is 36. If we look at the product to a power on the right-hand side, when we distribute the 2 to everything on the inside, 2 to the second power is 4, 3 to the second power is 9, and 4 times 9 is 36. You get the same exact answer. It's just a way to simplify exponents. Our whole goal in this section is simplify the exponents using these rules of exponents. Hopefully you're feeling like this is a little bit of a refresher. All right, a power to another power. So say we have something like a to the b power, and this thing is all being raised to another power, to the power of c. So it's like a to the b power being raised to another power, and that power could be anything else. I'm going to call it c. That's the same thing as taking the base a and raising it to the product power of b and c. When I'm saying this kind of stuff out loud, I feel like I'm speaking an entirely different language, and I kind of am. It's math. And hopefully you're feeling like this is a refresher. If not, with practice, it will get easier. It's hopefully, but it is a lot. So if we have an example like 2 to the second power raised to the third power. What the power to power rule says is you can take the base 2 and raise it to the product of 2 and 3, which is going to be 2 times 3 is 6. This is the same thing as 2 to the 6th power. Okay, so all 3 of these rules had to do with products and powers, which also include products in there as well. So all 3 of these are showing what happens when you're multiplying and what will happen with the exponents. So the next 2 are about quotients. Quotients mean, a quotient means to divide. So now we're looking at not when you're multiplying, but when you're dividing exponents. So if we have an example like a to the b power divided by a to the c power. Division can look like a fraction like this. This is division with a fraction bar. Sometimes maybe the problem might give you the actual division symbol, or like it might look like this, a to the b power divided by a to the c power. You won't see that often. Usually it will be given in fraction form like this. But anyway, if you have 2 numbers that have the same exact base, in this case the base of both of these numbers are a, you can take the exponents here and simplify them by subtracting. So what this means is instead of doing a to the b over a to the c like this, I can make it all into one base of a, and you subtract the 2 exponents to get your final answer. So it's basically the opposite of the product rule. When you're multiplying things with the same base, you add the exponents. When you're dividing things with the same base, you subtract the exponents. An example of this would be like 2 to the 5th power divided by 2 to the 3rd power. The only way the quotient rule works is if the bases are the same. Because these are both 2's, I can take this and I can put it all into one base of a 2, and I can subtract the exponents, the top one first, the numerator first, 5 minus the denominator 3. This simplifies to be 2 to the 2nd power. Now notice all of my answers that I am getting here, I'm leaving them in exponential form, meaning that the answers still have exponents in them. I'm not necessarily saying, okay, this final answer equals 4. I'm leaving it with the exponents just so you can see how it works, but if I wanted you to simplify further, you would then take your calculator and then get the final answer by putting it in. Yeah?
For the product rule and quotient rule, the bases are the same, you don't like multiply them?
No,
What
that's
if they're different?
if they're different, you can't use the rule at all.
Okay.
So that was a great question. So the question was, what if the bases are different? You can't use these rules at all if the bases are different. If the bases were, like, say it was like 2 to the second power times 3 to the second power. They might have the same exponent, but because they have different bases, the big number at the bottom, these rules do not apply. And what's strange about, like, the product rule, for example, is when you're multiplying, like, something here, 2 to the third power times 2 to the fifth power, you don't multiply 2 times 2 and get 4 ever. So you only take the exponents and do the little rule with it, like add them, and you leave the base completely the same. So that's what's interesting about it. The reason why, if you want to really look further, 2 to the third power is the same thing as 2 times 2 times 2, because it's 3 2's being multiplied. 2 to the fifth power is the same thing as 2 times 2 times 2 times 2 times 2, so there's 5 2's. Well, 2 to the third times 2 to the fifth is going to be all of them. So it's going to be 8 total. 1, 2, 3, 4, 5, 6, 7, 8. That's where we get that from. That's where the rule comes from. So you don't ever do anything with the base number. You just take the number of exponents, which is how many times that number is being multiplied, and you add them. For the quotient rule, it's the opposite of the product rule, because if you have the same thing, like 2 to the fifth power, that's the same thing as 2 times 2 times 2 times 2 times 2. That's 5 2's. And you're dividing it by 2 to the third power. That's 3 2's. What happens with division and fractions, whenever you have one number on the top and it's the same as the number on the bottom, they cancel out. So this pair of 2's cancels. This pair of 2's cancels. This pair of 2 cancels. You're left with 2 times 2 in the numerator, which is 2 squared, which is also equal to 4. So that's where this rule comes from. You're subtracting the exponents because each pair will cancel out. And then the last one is quotient to a power. If we have any fraction, a over b, and it's being raised to a power of, let's say, c, what we can do is we can take that power and we can distribute it to the numerator and the denominator, and you just keep the division there. That's the same thing as a to the c power over b to the c power. So for example, if we have a fraction, let's say 2/3, and we're raising this to the second power. If I said simplify this using the quotient to a power rule, what you would do is you would take this little exponent of a 2 and you would give it to the numerator and the denominator like that, and that's how you could simplify it using the quotient to power rule. And then in the end, if you wanted to find the final answer, 2 to the second power is 4, 3 to the second power is 9. This would simplify to be 4/9. But that's how the rule works. So these rules of exponents are the rules that you will have to follow for these first 6 problems here. And then there's a couple in the back that we'll do, and then we'll be learning some new rules. And these, unfortunately, these rules get really confusing when you complete problems. So just bear with me. Try your best. Make sure you're following along. For those of you at home, I can't see you. For those of you here, I can see everyone, so I can see those of you who are following along and writing things down. This is difficult stuff. Thankfully, everything will be recorded, so you can go back through and you can watch this lesson again. I could always send you more videos of somebody else explaining it if maybe what I said was confusing. But I really need you guys to pay attention, because after today, we're going to be learning even more. And then it'll get over your head if you don't stay with it and start like practicing these and studying these rules. So the first problem is asking us to simplify, or the first section asking us to simplify all of these problems using the exponent rules. So I see here 5x times y to the 4th power, and it's, for whatever reason, all in parentheses, and it's being multiplied by this product here, 3x squared. Technically, every single thing here is being multiplied. Like, this is really 5 times x times y to the 4th, and that is being multiplied by 3 times x squared. there's really no reason for those parentheses. I guess it's just showing you two separate things are being multiplied, but essentially everything is being multiplied here in this problem. When you are simplifying exponents, the first thing that you should do is simplify the coefficients. That means the numbers that are just actual numbers that have no exponents, no variables, no nothing. I'm talking about the 5 and the 3 here. So this 5 and 3 are coefficient numbers, we call them, and that's because they are not attached to any of the bases with the exponents. What you will do first is multiply these and put the answer all the way to the left. 5 times 3 is 15, so I'm going to put that all the way to the left. Whenever you have a final answer, the plain number in the problem should always come first, and then all of the variables with the exponents should come after. There's no certain way or order you have to put the exponents in those variables, but the number should always come first. All right, now I'm just going to move down the line, and I'm looking here to simplify x and x squared. You can only combine bases and exponents that have the same base. Like I can't combine x and y to the 4th power because the bases are different. This has a base of x, this has a base of y. I can combine x and x squared though because they have the same base. The base that they have is x. Right now there is an invisible exponent that this x has. Whenever there's no exponent there, you have to imagine there is an exponent of 1 there. Anytime you write any variable down like a, b, c, d, there always is an exponent there if you don't say it, and it's just 1. So when we combine x to the 1st power and x to the 2nd power together, this is going to be through the product rule. We could move things around, like if we really want to, we could move these two things next to each other. Like I could take the time and rewrite this problem. It's not necessary, but if it's helpful for you, you could rewrite it so the x's are next to each other. Using the commutative property, you could totally do that, but you don't need to. But what you do need to do is use the product rule to combine these x's. When you have the same exact base, what you do is you add the exponents. So this can simplify to be x to the 3rd power, and y to the 4th power has nothing to combine with it. So the answer would just be 15x to the 3rd power, y to the 4th power. That would be it for that final answer there. It's kind of hard, so I'm going to for me to circle my answer, so I'm just going to rewrite it over here. This just would simplify x to the 15x to the 3rd power times y to the 4th power, and that's it. It looks like it's a weird answer. It is a weird answer. Exponents will always look weird. The next problem. Again, these random parentheses are just showing multiplication, but basically everything is being multiplied. This is negative 3 times x to the 3rd power times x to the 5th power. We don't have to worry about these parentheses because there's no exponents on the top telling us we need to use a different type of rule, so we don't have to worry about it. So the only number that's a coefficient number that we have here is the negative 3, so there's nothing I need to do here with that. But what we do need to do is simplify x to the 3rd power times x to the 5th power. Using the power rule, I can combine these all together. X to the 3rd power is x times x times x. X to the 5th power is x times x times x times x times x. The power rule says, for products, is you could take the exponents and you would add them together. 3 plus 5 is 8, so this would simplify to be negative 3 times x to the 8th power, and that would be your final answer. All right, moving down the line, these kind of just have to be careful because the U's and V's look very similar with this format, this font that we're using. So I see U to the 3rd power times V times 2 times V squared. The first thing I'm going to do is move the coefficient numbers all the way to the left. That means that 2 there. I'm going to take the 2 and I'm going to write that first. There's nothing I need to multiply with it, so it's just going to stay 2. The next thing I'm going to do is look down the line and see if there's anything I can combine. I see one plain V here and V squared here. So I can use the product rule to combine V and V squared. Remember, V is really V to the 1st power. V squared is V to the 2nd power. 1 plus 2 is 3. So this would be V to the 3rd power and then times U to the 3rd power. Depending on the teacher that you have, some teacher might want you to put in your answer in alphabetical order, a certain way. Honestly, if you can get to this, I'm cool. You don't have to put it in alphabetical order as long as you have the exponents in the right spot and the math is all right. I don't care if the variables are out of order. So that's just me personally. As you get to higher level maths, your teacher might ask you to put it in a certain order. It'll be marked wrong, but not for me for this year. Questions? Okay. Moving on to letter D, we're going to do these together because these are different. So letter D says -3 times xy squared all to the power of 2. So this is the first example that we have to use a different rule. We have to use the power to power rule for this problem because the entire product of xy squared is being raised to a power of 2 here. What that means is using the rules, if you look above here to the one that says power to power, that means that this 2, to simplify it and get rid of these parentheses, this 2 is going to be getting distributed to both of the numbers inside of there. So that means that this x is going to get this power of 2. This x right now has an invisible power of 1 right now, and when you use a power to power rule, what you do is you multiply the exponent on the outside, this bigger exponent, by the little exponents on the inside. So x to the first power raised to the second power, 1 times 2 is 2. This turns into x squared. Y to the second power raised to another power of 2 would be y to the fourth power because 2 times 2 is 4. There's nothing else we can do to simplify that because we have just x's and y's. Those cannot be combined together because they have different bases. So that would be it. Notice we used a different rule here. We took the exponents and we multiplied them. In previous problems, we took the exponents and we added them. But this is a completely different rule. This rule is a power to a power rule. When you have parentheses, like in letter A, you have parentheses, and you have an exponent on the outside of those parentheses. That exponent on the outside gets distributed to literally everything on the inside, whether it's a coefficient number or a variable. That number on the outside will get distributed to everything on the inside. The numbers on the inside here are -3 times x times y squared. When I take this 2, I'm going to be distributing it to all 3 of the terms inside of the parentheses. Anything that doesn't have an exponent right now does have an exponent. It's just not written. The exponent is 1, and it's just invisible. So if it's helpful, you can write the exponents there so you can see them. If you understand that it's there and don't need to, that's fine. What you're doing here is you're taking these exponents and you're giving them to all the ones on the inside through multiplication. The power to power rule says you take a 2, multiplied by the exponent that's on the inside, -3 to the first power to the second power would be -3 to the second power like that. Times x to the first power to the second power would be 1 times 2, which is going to be x squared. And y to the second power to another second power would be 2 times 2 is 4. This would be y to the fourth power. There's nothing we can do to simplify this problem, so it is what it is. It's just -3 squared times x squared times y to the fourth power. Actually, I can simplify this. Just kidding. I can simplify this because this is not a variable. This is a coefficient number. -3 squared, I can simplify that to just be -9 x squared y to the fourth power. So that's what I would want you to have as your final answer because -3 squared is -9. Okay, and then this last one is going to be the hardest one because we have to use 2 different rules in one problem. So far, all of the rules that we've used just required one of the exponent rules, not more than one. So looking at this, we have -3x to the second power times x to the fifth power. We need to simplify this power to power rule before we do anything else. So -3x to the second power is the same thing as -3 to the second power times x to the second power, like that. I got that by taking the power of 2 on the outside and distributing it to everything on the inside. So now I have -3 squared, which is the same thing as -9. So So I have negative 9x squared, and I need to multiply that by x to the 5th power. Notice I got rid of the parentheses because these parentheses right here and right here were only being used at this point just to show multiplication. Before, the parentheses were needed to show you that this was being raised to a power of 2. But now that I did raise it to a power of 2 and I got rid of that, I could drop them and just use this dot here for multiplication. But if you prefer to use the parentheses for multiplication, that's fine as well. We can simplify this further. Since we have two numbers that have the same base, I'm talking about x squared and x to the 5th, I can combine these together using the product rule. The negative 9 stays where it is, but x to the 2nd power times x to the 5th power. This is where it gets very confusing. We just took exponents and we multiplied them essentially. But now when we're multiplying two numbers that have the same base, you don't take the exponents and you multiply them. You actually add them. This is a product rule problem. X squared times x to the 5th is the same thing as x to the 7th power. And that's because x squared is x times x, and x to the 5th power is x times x times x times x times x. Altogether, we have 1, 2, 3, 4, 5, 6, 7. That's where we get the 7 from. So if you flip this over to the next page, there are two practice problems that say you try. I'm going to give you guys a couple minutes to try these problems, and then we will go over them. All right, let's go over these. So your whole goal in simplifying exponents is, number one, anything that's a plain coefficient number. That means like it's a solid 4 or a solid 2. You want to simplify those and just have all of those numbers, whether they're multiplied or whatever, you need to have just one plain number in the front. So you might want to get rid of those and try and find those first if possible. And you want to get everything as simplified as possible, and when you get your final answer, you should have no parentheses in your answer at all. A simplified final answer might have a plain number in the front, a coefficient number, and then it might have a series of different exponents, and that's fine as long as the exponents have different bases. But if you ever have two of the same bases, meaning you have two of the same exponent bottom parts, like the same variables at the bottom, those can be combined using one of the rules. So looking at these two problems here, the first one, I automatically look to see, are there any parentheses in the problem? And if there are parentheses, are there any exponents that need to be distributed to anything on the inside? Well, this one doesn't have any parentheses, so I know that I don't need to use a power to a power rule first. That is the first thing you have to do if it is there. But there are no parentheses, so I don't have to worry about that. Then what I'm going to do is get rid of the 3 and 2 by multiplying 3 times 2 like I normally would and bring that coefficient number on the outside. 3 times 2 is 6, so I'm going to bring the 6 on the outside here. That's the first number I'm going to write down. Always is my coefficient number. That's the only thing that I specifically want you to make sure you put first is the coefficient number. And then you look down the line of the problem to see, are there any numbers with the same base that can be combined using a certain rule? And the answer to that is yes. There is a y to the third power and a y squared. They have the same base of a y. So you would use the rule that says if you have two numbers that have the same base and are being multiplied, you take the exponents and you add them. 3 plus 2 is 5. So this simplifies to be 6 times y to the fifth power. That would be the final answer for this one. If you're ever confused, like should I add them? Do I multiply them? Think about what's happening. Think about how many y's are in y to the third power. There's 3. Think about how many y's are in y squared. There's 2. So there's 3 y's here, there's 2 y's here. It makes sense that altogether there's 5 of them. That's why this 5 is here. Looking at number 2, like I said, the first thing you should look for is parentheses to see if there's any power to power rules that need to happen, and if so, you have to do that first. Well, looking at number 2, the first thing I see is 2 sets of parentheses. I see 3y in parentheses, all being raised to a power of 3, times 2y squared in parentheses. Well, these parentheses right here need to be simplified first because it has a power to 3 here, which means you have to use the power to power rule first. The power to power rule says you take this power of 3 and distribute it to everything on the inside. That means that this 3 to the first power, that's invisible right now, is going to get the power of 3 through multiplication. 1 times 3 is 3, so this is the same thing as 3 to the third power. And this plain y, which right now is y to the first power, but you don't see the 1, is going to get the 3. 1 times 3 is 3, so that simplifies to be 3 to the third power times y to the third power. 3 to the third power times y to the third power is being multiplied by 2y squared. You can keep the parentheses if you choose, or you can delete the parentheses and just use like the floating multiplication symbols, which is what I prefer to use when I don't need parentheses anymore. So the next thing I'm going to do is take my coefficient numbers and multiply them. That means 3 to the third power times 2. You could do this right in your calculator. 3 to the third power times 2, hit enter and get it. Or 3 to the third power is 3 times 3 times 3. Well, 3 times 3 is 9, 9 times 3 is 27, and then 27 times 2 is that 54. So we get 54 here. And then the last thing we would do is simplify y to the third power times y to the second power. Well, we would do this through the product rule. Since these are being multiplied, you would add those exponents. This would be y to the fifth power. That would be your final answer altogether. So we didn't get as far as I thought, which is fun.